Alright, now let's do the reverse. Okay, scroll down. You are now supposed to convert from binary to decimal, or octal to decimal, or hexadecimal to decimal. If decimal is in the right side, if decimal is the answer, यदि हाम्रो answer चाहिँ we want the answer in decimal. What you have to do all the time most is multiply. Okay, multiply by what? If the target is binary, we always multiply by 2. If it is octal, multiply by 8. If the question is hexadecimal, we always multiply by 16. And not just that, we also have to see the positioning, where the digits are, the positioning. So for now, I'm just gonna give it n, like this. Alright. So this is the way. Let's see the first question. 1, 0, 1, 1. So this is in base 2 binary, and you are supposed to convert this into decimal, base 10. So how are we going to do that? So here in this scenario, at first we have to look at the positioning of all these digits, okay? And positioning we always start counting positioning from right to left. So this is right side, we write 0 here. This is 1, this is 2, this is 3. Based on the positioning, what you're going to do is, look here. First digit is 1, right? You write 1 times 2 to the power position 3 plus the second digit 0, right? 0 times 2 square, okay, plus 1 times 2 to the power 1 plus 1 times 2 to the power 0. Okay, so we know that, here 1 times 2 cube means 8, obviously, and 0 times anything it's 0, so let's just ignore that. 2 square is 4 anyway. So 1 times 2 to the power 1 is 1 times 2 plus 1 times 2 to the power 0. 2 to the power 0 is 1. According to laws of indices, obviously, any number to the power 0 is 1. I mean, like, if you do, right, 100 to the power 0, this is 1. If you write 999 to the power 0, this is also 1. Okay, so no, this is laws of indices. Any number to the power 0 is 1. If you add this off, right, 8 plus 0, ignore it, 2 plus 1, 8 plus 2, 10 plus 1, 11. So this is our decimal equivalence. 1 is equal to 11 decimal. This is one way. We also have other faster trick to do it. So based on this positioning, we know this is in the position of 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, like that. We know that, right? Based on this positioning, we know that this is in the position of 2 to the power 0, this is power 1, this is 2, and this is cube, right? And these, these values, these are called binary positional weight. Again, what did I say? I said these values are called binary positional weight. And it is same in every question. For example, the last digit would always be 2 to the power 0, and then 2 to the power 1, 2 square, 2 cube, 2 to the power 4, 2 to the power 5, and so on, like that, okay? And 2 to the power 0 is always 1. 2 to the power 1 is 2. Power 2 is, cube is 8. 2 to the power 4 is 16. Power 5 is 32. So as you can see, they are always doubling up, right? 1, 2, 4, 8, 16, 32, like that, So we know, like, so I'm gonna give you the faster way to solve it. So what are you gonna do? So instead of writing all those things, so we have this question. 1, 1, 0, 0, 1. And we have to convert this into decimal. Based on this thing, So at first, in your answer sheet, what are you going to do? You write solution equals 2, and you write something question, right? 1, 1, 0, 0, 0, 1, 1. Okay, this is our question. And you put the binary weight. You can write here, you know, you can write here binary weight like this, some colon here, and just directly write the equivalent binary. Let's say this is in the position of 1, 2, 4, 8, 16, 32, and 64. Right. Now, whatever value has 1. So just value 1, so we just take that, we just 64 1s are 64. We wrote right here 64. 32 1s are 32. 0, 0, 0, 8, 0, 0. We take that correctly. Take this 2, 2, plus 1. So 64 plus 32. And 6 plus 98, 99, I guess. So 99 is our target decimal equivalent of this binary. You know what I'm saying? Alright. Now similarly, you are supposed to convert octal to decimal. Okay? Is, say 7, 3, 4. So let's say this is our octal value, 0 to 7 octal. We are supposed to convert this into decimal equivalent. So based on this formula, what are you going to do? Here we write our question. Basically, we write the positioning. I'm going to show you the positioning. This is in the position 0. This is position 1. This is position 2. We can write something like that. And after that, we write something. Look here. 7 times 8 square. Because we're gonna multiply with 8. You know what I'm saying? Based on our formula. If our target is decimal, multiply 3 into 8 to the power 1 plus 4 into 8 to the power 0. Okay. So 7 times 64 plus 3 is 24 plus 4 into 8 to the power 0 is 1. Okay. 7, 6. This is our decimal equivalent. Question 6. Now, similarly, let's convert hexadecimal to decimal. Okay. AB. So this is in hexadecimal. We are supposed to convert this into our decimal equivalent. So how are we going to do this? So at first we always write the positioning. Let's say this is in the position 0, this is 1, this is 2. And based on this positioning, let's say 2 into 16 square, right? A into 16 to the power plus B into 16 to the 0, okay? And then this 2 times 16 square, I believe it's 256. A means 10, right? So no, right, 16. So B means 11, right? 16 power 0 is always 1. 256 times 2 is 500, times 2 is 512. 16 times or 160 plus 11, basically 683. This is our decimal equivalent of 280. See,